And we're going to start, I guess we could call it Chapter 1B. This is going to be lessons 1.4 through 1.6. And they're very,
Wait, all today?
no, this is just the start of the new chapter. They're very disjointed ideas or concepts. None of them really go together. Like we're going to do parametrics, logs, and trig. So it's just all review of stuff last year. Okay, so let's start 1.4a. We're going to do some parametric equations. And parametric equations was right before we did polar graphing in HAM last year. So parametric is the one with the T in it. I don't know if some of you remember that. Okay, so let me go ahead and show you what a parametric graph is. Now, if you haven't done parametric or polar graphing, you don't know that your calculator can do a variety of things. Let me pause your calculator. Okay. All right, so let's talk about some relations. Now, parametric equations aren't necessarily functions, because when you're in function mode, all you can graph are functions. That makes sense, right? But parametrics, you can graph anything. It doesn't have to be a function. It could be a function. Okay, so what you have is you're going to have x is going to equal some function of t, and y is going to equal, a different function. A different function of t. Or it could be the same, but it's usually different. Okay, and what you're going to do is you're going to graph, your points are going to be the x and y's. All the x and y's that you get. You actually don't graph t. It's very strange. It's not a 3D graph. There are 3 different variables, but it graphs on a regular xy plane. And this is called a parametric curve when you graph them. So let's go ahead. Let's do one just to show you what they look like. Number 1, suppose that we have x is equal to the square root of t, and y is equal to t. And I'm going to restrict t. Sometimes t is restricted. Sometimes it's not. I'm going to say t is greater than or equal to 0. So I'm going to show you how to graph by hand first. Most of the time we're going to do these on our calculator, but if you didn't have your calculator, you needed to graph by hand, this is how you could do it. So we're going to graph. And what you're going to make is, instead of like just a t chart with x and y, you're going to make a bigger one. You're going to have values of t, x, and y. And so our values of t are going to be greater than or equal to 0. So I'd probably go 0, 1, 2, 3, so on and so forth. That'd probably give me enough. And then what you do is you take that t and you're going to plug it in for x and for y. So when t is 0, what's x? 0. When t is 0, what's y? 0. Plug in 1 now. When t is 1, x is the square root of 1, which is 1, and y is 1 also. So far, it's pretty boring. 2 goes in, and I get the square root of 2, which is what, 1.14? 41. I always do that. 1.41. And then 2 goes in, and we get 2. Square root of 3, anybody know it? 1.73. Dang, girl, you good. 1.73 with 3. Let's do 4, because 4 is going to turn out nicely. 4 goes in and gives us 2 and 4. Okay, so you're looking at this table of values, and you're like, whoa, that's a lot of information. How am I going to graph all of that? Well, you're just going to graph the x, y points. You don't graph the t's, okay? So you go over here and you draw your x, y plane, and then you just plot your points. And I'm going to plot the nice ones, of course. I'm going to plot 0, 0. We're going to plot 1, 1. We're going to plot 2, 4. And this kind of looks like something we've graphed before. Doesn't it? Do you recognize those points? Yeah, it's just a parabola. But it's only half of the parabola. Okay? So this one right here is just a half parabola. And they're going to have you do a couple things to this. Okay? So the first thing that they'll do is have you graph it. We graphed it by hand. I'll show you how to do it on the calculator in just a minute. They will ask you to eliminate the parameter. Eliminate the parameter. And that sounds so fancy. What they want you to do is they want you to get rid of t. They want it just in x and y, so that if you wanted to graph it on an xy normal graph, you could. So what you would do here is you would just solve for t for one of them. One of them's already solved for t, the y is. So you can take y equals t, and you would just go and plug in y in for x, or yeah, that's probably better. Yeah, so you could have x equals the square root of y. Nobody really likes that because you want it to be like y equals as a function. You could do that. You could square both sides and say y is equal to x squared, but you'd have to make sure that you do one of two things. You would say x has to be greater than or equal to 0 because it's only the right side. Or you would actually just write right side of parabola. And they allow that, which I think is kind of funny, instead of like mathematically saying it. Okay? All right, let me show you how to graph this on your calculator now. Pause. Do you guys remember doing these at all? Hand people? Yeah? No? Yes? No? Okay. All right, now, if A is less than or equal to T is less than or equal to B, so if T is between A and B, we say that your graph is on a closed interval. A closed interval. Okay? And then if your graph is on a closed interval, then it's going to have an initial point. And I'll tell you what that initial point is. And it's also going to have a terminal point. So if T is from A to B, it has a starting point and it has an ending point. And the initial point would be the point where you plug in f of A, comma g of A. That's going to be your initial point, is to plug in the first t. That should make sense. And your terminal point would be to plug in the last t, which would be b. F of b, comma g of b. Okay, so let's go ahead and do some more fun things than just relations. So let's do some circles now. Now, you weren't able to graph circles unless you graphed two different equations, right? You would have to graph the top half of an equation, the bottom half of an equation, because a circle is not a function. But we can graph them very easily through parametric graphing. All right, circles are going to look like this. X equals a cosine t. Whoa, there's cosine. And y equals a sine t. And yeah? And those a's are going to be the same. Okay. All right? For a full circle is going to be t is from 0 to 2 pi. Because that's going to get you all the way around. We're going to review trig stuff, but you know that 2 pi is all the way around the circle. 2 pi radians. All right, these I will not make you do by hand, okay? We'll do this, the whole thing, on our calculator. All right, number 2. So what we're going to do is we're going to graph. We are going to list the initial and terminal points. Initial and terminal points. And we are also going to eliminate the parameter. Let me see. Okay, your book says find a Cartesian equation for a curve that contains the parameterized curve. All right, maybe I should write that instead. We're going to find a Cartesian equation. Basically, all you're doing is getting rid of t. You just want x and y's, okay? All right, here we go. Let's go ahead and we're going to do a few circles. So let's start off with this circle. X equals 2 cosine t. Y equals 2 sine t. And t is from 0 to 2 pi. T is from 0 to 2 pi. No, because 0 and 2 pi are the same thing. So, I mean, you could. It wouldn't matter. All right, so let's go to our calculator. Here we go. Okay, so when they ask you to graph it, try and draw the best graph you can. You can also trace it, and you can go around the circle, and you'll get actual points. Okay? But it goes out to 2 in each direction, and it goes like this. And actually, parametrizations have they have a direction too. I'm not too picky on that, but the correct way would be to be like going like this, because that's the way the parametrization went from 0 to 2 pi. It went around the circle. Sometimes it can go the other way, but it doesn't matter. Okay. Our initial point is when t equals 0. T equals 0. Maybe I should have included 2 pi, because that's our terminal point. Oh well. All right, our initial point is at the point 2, 0. That's where our graph started. This was when t equals 0. And my terminal point is the same exact point, 2, 0. And that's when t was 2 pi. And I really should bracket that in to say it's 0 to 2 pi. Okay? What's that?
Terminal point is where it ends.
Yep, terminal point's where it ends. So the terminal point's not always going to be the initial point. Let's do another one. All right, B. Let's do x equals, oh, I didn't do that last part, did I? Okay, sorry, go back. I know, I forgot. We have to eliminate the parameter. Now, some of you guys remember the equation of a circle. Do you remember it? X squared plus y squared equals r squared. Okay, that's easy, right? No big deal. It's centered at the origin. We're okay. So this would just be x squared plus y squared equals what? 4. So yeah, the radius is 2. So that would be 2 squared is 4. Okay? That would be to eliminate the parameter or to write it as a Cartesian equation. That's a Cartesian equation. It has no t in it. Let me show you another way to do this if you ever didn't know the equation of a circle. So we have x equals 2 cosine t, and we have y equals 2 sine t. Go ahead. You do? You remember this? Yeah. Go ahead and divide by 2 on both of them. So you get x over 2 is cosine t, and y over 2 equals sine t. Do what? Mm-mm. So now what I'm going to do is I'm going to square everything. Square both sides of the equations. And I get x squared over 4 equals cosine squared t. Oh, yeah, you have to do cosine t parentheses with the squared. And then y squared over 4 equals sine squared t. And then check this out. Let's take these and add them up. This is so fun. You get this side, yes! X squared over 4 plus y squared over 4 equals cosine squared plus sine squared, which is 1.
Times everything by 4 to get rid of the denominator.
Yep, multiply everything by 4. There it is. So cosine squared plus sine squared equals 1.
Well, that's an ellipse, but then since it's the same base,
Oh, it's a circle. Yeah.
Yeah, but
Yep.
I'm saying, like, if it was different.
Yes, we're going to do that too. Ellipses coming up.
Today?
Yeah. We have time.
Stop trying.
This is when you stop trying? No. All right, let's try another one, number 3. Okay, this one's going to be a teeny bit different. Not too bad, but let's say that x equals 5 cosine t and y equals 5 sine t. And this time, t is from 0
And is number 3 or
to pi. This is b. You're right. See, the problem is I can't see what I've written because it's gone, you know? You're like, no, not at all. All right, 5 cosine t, 5 sine t from 0 to pi. A little tiny bit different. I changed the radius. and it's a half circle. You knew that already. That's great.
Is A the radius?
It is. All right, so go to your calculator.
Wait, Minecraft don't circle.
You did because you didn't change the window. Okay, so what you have to do is if you hit zoom 6, your t is going to normally graph 0 to 2 pi. So you have to go into the window and change t.
Now my thing just has a change to 36.
Okay, change t. And then what we're going to do is we're going to draw a graph of it. We're going to say the initial point and the terminal point. Initial and terminal, and let's find it. Okay, so we get, here's 5, here's negative 5, and we get that, just the top half of the graph. So what's my initial point this time? Where did my graph start? Started at the point 5, 0, and then where did it end? Negative 5, 0, exactly. And you can look at your graph, especially if you graphed it correctly, you can see that's where it goes. Yeah, t has to go from 0 to pi. Make sure you're in radian mode.
Yeah, put it back in radian mode. My calculator went back if you had it in degree.
I mean, you could go 180 if you wanted to, but bleh. Okay, and then to change this into a Cartesian equation, okay, without the parameters, you would say x squared plus y squared equals r squared, which is 25. But that is an entire circle. So you would need to do, yeah, you could say top half. I'm perfectly fine with that. Top half, okay? You could solve for y and just take the positive square root instead of the negative square root. The negative square root is going to make the under part, but I don't need you to do all that. Just say top half. It's fine.
If you were to write it like as just like the range, y
Yeah, y would be fine. You can't write the domain negative 5 to 5 because that could include the under part. But if you wrote, that's a really good idea. If you wrote 0 to 5 for y, that would be perfectly fine too.
Okay.
Yeah. All right, let's do the last part. Let's do ellipses. Ellipses are going to be pretty much the same thing. But as you noticed on the last two, the number in front of the cosine t and sine t were the same, 2 and 2, 5 and 5. An ellipse, it's going to be different. But let's remember what an ellipse equation is. It's x squared over a squared plus y squared over b squared equals 1. Okay, that's centered at the origin. We're just doing basic stuff. Okay, we can have them not centered at the origin, but right now we're just going to have them centered at the origin. So let's go ahead and do number 3. So let's graph x equals 3 sine t. Sine and cosine, it doesn't matter which one's which. It really doesn't. It matters on like the orientation, like which direction it's going. And y equals 4 cosine t. And let's say that t is from 0 to 2 pi. 0 to 2 pi. All right, so we're going to do a couple of things. We're going to graph. We're going to write a Cartesian equation. We're going to find initial and terminal points. Yeah?
Yeah.
Yeah. Oh, am I kind of off the board? 0 to 2 pi. We're also going to talk about the major axis, the minor axis, stuff like that. Yeah, we're almost done. This is it. We graphed it on our calculator, and we're going to go out to 1, 2, 3, 4, and 1, 2, 3. They're very close, 4 and 3, so it might look like a circle to you. Did you see it when you graphed it? Did you see where it started and where it ended? It actually started up here. Did you watch it? It's really good that you watch it because that helps you get the initial and terminal points. So the initial point is up here at 0, 4, and so is the terminal point, 0, 4. Yeah. Yeah, you can. You would have to take 0 and plug it in for sine of 0. So the sine of 0 is 0. So x would be 0. And then you plug in 0 for this t, and you get that cosine of 0 is pi, or I'm sorry, 1, and 4 times 1 is 4.
Okay. Can we just do
Yeah. So if you ever needed to, though, but this right here is the initial point. You would plug it in over here, and this right here is terminal.
Oh, so you plug it in y.
No, you plug them in for t. This goes in for t, that goes in for t, that gives you y coordinate. Exactly. Okay, so let's go ahead and write this as a Cartesian equation. So this would be x squared over 9, good, plus y squared over 16 equals 1. And I know a lot of you guys haven't had conics since Algebra 2, am I right? Yeah. Ham did conics last year, so that's a little fresher in your mind. But that's what it is. If you didn't know that, you could have divided by 3, divide by 4, square everything. You'll get the same thing. Sine squared plus cosine squared is 1. The same thing.
Does it matter where the 16 and the 9 are?
It does. Yeah, so this goes out 3 on the x, so that's going to be 9 underneath the x. And this goes out 4 on the y, so that's 16 there. Okay, major axis length is 8. I might ask you that. Remember that? I'm sorry, I'm so boring. It's not the teacher, it's the subject. All right. Don't hate the teacher, hate the subject. All right, and then the minor axis length, 6. Perfect.
I don't think I gave up quite yet.
Oh, good. Don't give up yet. It's only